reset that.
That's good to hear that you're trying to do right by both of these projects.
All right, guys, I think we're going to get started. We're just a couple minutes after 7. I was just going to give a couple extra minutes for anybody else that had RSVP'd but not made it in yet. So thanks, everybody, for coming. Some of you already know me. Those of you who don't, I'm David. You're in the right place if you're at the .NET Meetup or the Frederick Game Dev Meetup. So we're going to be building a game in Unity today in really, really rapid fashion. You're going to hear me say, for the sake of speed, a lot. But for the most part, hopefully we'll get something out of it. I have a couple slides. That was my normal slide. So iHire is a sponsor of this meetup. Thanks to iHire for the pizza and beverages. iHire is an online job board. We run 56 different talent communities in pretty much every industry you can imagine with jobs all over the country. So iHireTechnology.com, iHireWhatever.com. We probably run it. I work at iHire, full disclaimer. I don't know if that makes a difference or not. It's a really awesome place to work. This is just some pictures of some really fun stuff that we do there. So, yay, iHire. You are at Fitzy. Fitzy is nice enough to let us use this place for our meetups. Fitzy is a public-private accelerator. So if you've got an idea for a business, Kathy, the CEO, and her team here are tremendous fundraisers and resources and networkers for everything, financial, legal, whatever you need to start an idea. So if you're ready to take the plunge and quit your day job, come work at Fitzy. I also always throw a slide in here for Tech Frederick. So Tech Frederick is a local nonprofit that wants to foster tech growth in Frederick. It wants to make people aware that there are tech jobs here in Frederick, and as well as tech companies here in Frederick. We have lots of events. Most of them are free. We have quarterly networking events. We have every couple months there are some breakfasts. Usually have a speaker talking about some tech-related topic or another. Those usually cost a couple bucks, but they're not prohibitively expensive. The networking events are a lot of fun. We have Frederick Tech Games every summer. That kind of thing is growing pretty rapidly. And my last promotional slide in here, I will let Adam jump in here and tell us about the Paper Jam.
Yeah, so we at the Frederick Game Dev Meetup, the Frederick Game Dev Meetup, which you should join if you're interested in making games. We try to do game jams throughout the year, and we have a great space over at Cowork where we can basically have this awesome space for the entire weekend. So kind of round the clock. So you can always bring your own game project to work on, or come and participate in the jam. There are a bunch of us who are regulars of this who are professional Unity developers. So including myself, Greg, and I mean I feel like you're basically professional. And so it's a great supportive environment. We're changing it up this time, and we're trying out a physical board game, card game sort of jam, which is a great way to prototype game ideas before you start writing any code, or even just make a game like that. And I have a lot of experience doing that, so I'm going to have lots of materials and stuff. So yeah, thanks for letting me plug that. Check us out, Frederick Game Dev Meetup.
I've met with the game dev group several times over the last couple of years, and we've ended up. I came with the expectation to learn things about Unity, and we ended up doing paper game tabletop prototyping, and didn't want to leave. It was very compelling, just to be able to throw together something so random and build out different game mechanics and things like that. So that's at Cowork as well?
That's going to be at Cowork.
Okay. Is it
Saturday 10 a.m. through Sunday, what did we say? 5
or 6 or something like that, yeah. And it's in the building next door to Cowork, which is their
new Cowork space?
New Cowork space, yeah. It doesn't have a sign, but we'll have a sign up on the door.
Cool. In case I forgot to mention it, I am streaming this, so just keep that in mind as you're asking questions or whatever. I encourage you guys to use this as an open conversation. I'm going to rush through some things, but we'll try to do it. There were a number of people that said they were going to attend virtually, so we're just streaming it on Twitch, so I've got a copy of this. So worst case, you'll at least have the video of it if you wanted to come back for reference, but I'll try to post whatever files we build today. Cool, so hooray game dev. All right, what's game development? Process of design and creation of a video game. So game development's more than just what you might watch on Twitch. There's so much more that goes into it for all different levels of game development. Everything from the solo indie developer up to the studio with a $70 million budget to create the latest Call of Duty or whatever it is. While we're at the .NET meetup, I also just want to talk about how this follows many of the same principles as the software development lifecycle. So continuous integration and deployment, different build platforms, having to target different consoles. So we're going to be looking at a mobile game today. We're already going to be addressing a couple of the problems with screen resolution. Probably everybody in this room has a phone with a slightly different resolution. So we're going to talk about some techniques to address that type of thing. And we talked about how it varies by platform. Unity is a platform that we can use to build mobile games, console, PC, what have you. There's a lot of different possibilities there, as well as AR, VR, things like that. I don't know a whole lot about AR and VR development in Unity, but I'm led to believe it's possible. So what are we building today? I play a lot of little dinky hyper-casual games. Some of them are ridiculously complex, some of them less so. We're going to put something together similar to this, where we're going to have a square up on the screen that we can drag our mouse or finger, if you're on a mobile platform, around. That white ball is going to just move around on its own at a static velocity or something like that, and the goal is to try and get it to overlap with the black hole, the black sphere that's there. So the mechanics are basically making that cube rotate, making the ball move, and then detecting whether or not that sphere, the black sphere, has the white sphere completely inside of it. So we're going to go into the details of those couple things. Time permitting, we'll also go into wiring up a new level, maybe the timer. We'll come up with some kind of scoring mechanics, maybe on the fly, because I didn't actually specifically plan for those. So we'll just kind of judge those as time progresses. Couple vocabulary words just as you're keeping up. Unity is a game engine, so we're going to be working in Unity only. Unity is a game engine that runs on the .NET platform. It targets the .NET platform, so as the .NET meetup, we're going to be writing C# code. It's not really a prerequisite for this. If you are trying to follow along, it's probably going to help a little bit unless you're able to follow my every keystroke. If you're not, don't worry. As Adnan had asked, I will try and post all of these files. Again, we're probably going to be writing maybe 30 lines of code, so it won't be terribly complex. Some of the mathematics might seem a little foreign, but I'll try to walk everybody through those. Unity uses the entity component system, so everything is an object. Think object-oriented programming, if you've ever heard of the concept before. These objects have different components. They're going to have a way to display them on the screen. They're going to have a way to detect collisions with other objects. They're going to have a way to indicate where they are in your world space. We're going to talk about the difference between world space and screen space. As you're clicking on your screen on your mobile phone, or if you're moving something around, if you're on your Xbox or what it might be, there's going to be some user interface elements that are in screen space, but your objects themselves, your entities, the guy that you're shooting at or the ball that you're clicking or something like that are going to be in world space. So we need to make some conversions for those types of things. Directions and dimensions and lots of different things. I just added vectors and trigonometry here, not to intimidate anybody. If you don't understand what it is, I'll try and give a 50,000 foot view as we hit that. The trig, don't worry if you haven't taken pre-calculus or calculus very recently. I'll go into the couple trig functions that we're going to use. Frames per second. So one thing to consider in game development is that code can run a lot. If you're running a game in 60 frames per second and you have a segment of code that runs in every frame, you need to consider that type of thing for performance. We're going to be looking at a couple of those. We're going to be writing some code that lives inside of some of those functions today. So we'll talk about what that means from a processing perspective, what it might mean if you ran something that took too long, and it might make that frame last too long or slow the game down to 20 frames per second or something like that. Unity Hub is a tool that we're going to just briefly touch on in the beginning. If you're at all serious about getting into Unity development, Unity Hub is going to help you. It just helps you manage different versions of Unity. They're on a new release cadence at this point that is quarterly, but there are also patch and minor releases every so often. Unity Hub will allow you to manage the actual install for your project, because just if you built something in 2018, there's no guarantee that it'll work perfectly in a 2019 version, or 2019.1 might not be appropriate for a 2019.2 build or something like that. Unity Hub will allow you to manage that. I threw this last one in here, materials for making things shiny. That's basically the extent of what we're going to do with materials here. We're not going to be writing any advanced shaders or anything like that. We're going to make a couple materials in the beginning of the project just so things are colored and easier to see on the screen. Because this is an introductory talk, I'm sure that Adam or Greg would love to talk to you guys about shaders, whatever those fancy things are after this. So we already kind of talked about what we're building. Those are the 3 core components of what we're going to be building through this segment. So a big square that rotates when you drag your finger around. So we want to be able to drag our finger around 720 degrees, however it is, but we want to make sure that it's not a jarring experience. We want to create an intuitive experience. So we'll go into some of the math about how we calculate, how to make sure things run smoothly. The ball that moves automatically and doesn't leave the area, the ball should stay within that square. And then this black hole target that lets us finish the game or finish the round. So time permitting, as I mentioned earlier, we'll add a new round. We might just copy some things and tweak some things to make the round the second level harder or something like that. All right, so that was it for slides. So I want to dive in. We're going to come back to the slides a couple times just for my reference sake. So for this first segment, we're going to make a cube. We're going to make more cubes into borders. We're going to remove most of that main cube, so it's going to be a hollow square, basically. We're going to add a script, and then we're going to do a whole lot else. That's where the magic bullet is. And hooray, our big cube spins at this point. So I'm going to drop this out of full screen and see if I can maneuver all my windows around. So I have Unity Hub open here in a second. This is Unity Hub. These are the 4 different versions of Unity that I have installed on my box right now. We're going to be in 2018 for 1F1 just because it's a long-term support version. We're not doing anything sufficiently advanced that I don't think you wouldn't be able to follow along in 2019. I don't think I've actually built anything in 2019, any of those versions yet, but that's the idea. So this is what's selected now. We'll add a new project. We'll select our version, 2018. Where's my version? Is it this one? 3? No, that's 4F1. Oh, I'm adding the new Unity version. I'm sorry. Thank you. I'm going to come in here and new. There we go. New project with 2018 for 1F1. Don't worry if your version isn't identical. We're going to leave it at 3D. Our game will be visually 3D, but we won't be moving the camera around or anything like that. We're going to call this one Black Hole Meetup Demo. Your Unity, your mileage may vary when your Unity opens up if you're trying to follow along or if you're looking back on this, as I know you all will. But we're only going to be working with a couple of the different panes in Unity. So when you open it up, if your tabs are split in a different way, I've just rearranged mine. Don't worry that you're not using the right version. We're only really going to be working in scene view, the game view, the inspector, which is what shows us lots of different properties about our various components, and the hierarchy, which is just where the list of all of our objects are. No, this is native. So, but your Unity will look essentially the same, despite the fact that I'm running on a Mac and you might be running on Windows. No, this is all native. So let me move this over to the screen that I'm actually streaming on. So, yeah, when you install Unity, it'll ask you about which platforms you want to target. WebGL, which would be a web-based build, iOS, Android, Xbox, whatever you want to actually target, you can pick those. My primary interest is iOS and Android. The beauty of it is I get to write C# code one time and I get to run it on different applications, different platforms. Asterisk. There are some small contingencies that you need to consider depending on features you're using, none of which we'll be talking about today at an introductory level. So when you open yours up, you might have your game and your scene tabs together. I've just split mine apart. Your game view might also look different than this. I've already added a couple resolutions that are specific to mobile. So if you're in a 1280 by 720 or an 800 by 600, feel free to add another one. This one specifically is 1242 by 2208. That happens to be the scaled out resolution for iPhone 6 Plus, 6S Plus, all the way up to the 8 Plus. And then I also added the XR. That's the phone that I have. I just wanted to show that it's ridiculously skinny. It's like 2 to 1 or just greater than 2 to 1 or something like that aspect ratio. So while we're looking through this, occasionally I'll flip over to this to make sure things aren't out of bounds or something like that for the XR. We'll talk briefly about some techniques to scale things, but we're not going to go into scaling things in this talk. So that might just be the slight difference in your environment. 1242 by 2208 in my game view. So your default scene, you start with a main camera and a directional light. We're not going to touch either of those. Our camera is already pointed in a direction, so we're just going to dive in and put things in front of it. So this is my hierarchy over here. Yours will probably be on the left with the default install. Your inspector should be on the right. If it's not, try to find that. That's what we're going to be working in. The first thing I'm going to do is get rid of this skybox background. So with my main camera selected in my sample scene, I'm going to change this over to a solid color. It's going to make looking at some of the cubes as we place them into the scene a little bit easier to see. Otherwise, we're going to be using the perspective camera. No other settings we're going to tweak for the purpose of this project. So we'll be able to build what we saw in the earlier slide with just this camera in this position. First thing I promised we were going to do was add a cube. You can do that by right-clicking in the hierarchy and going to 3D Object and Cube. You can go up to Game Object and get the same types of menus. However you decide to do it, let's go ahead and add a cube. Rule of thumb, whenever you add a new object to your scene, go ahead and reset it. So with the cube selected over in the inspector, you click this little gear icon on the transform component. That's this area right here, and click reset. It just resets it back to 000 XYZ position and a normal scale. So this is, for the purposes of this conversation, a 1 square meter cube. We're not going to go too much into the units. We're going to talk about angles and things like that a little bit later. So we've got our cube. I want to scale it up just a little bit. I'm going to go to, I happen to just remember what some of these numbers are. Some of this is going to be trial and error for you guys. This is roughly going to be the size. We're going to be adding some border cubes outside of this to make our object. This object right here is going to go away long term. We're just going to add some cubes on the outside as borders. I'm going to move my camera around a little bit so our scene view looks a little similar to our game view, and maybe some of it will be a little bit easier to see. So you can see if I want to move my object up, down, left, right, whatever it is, by toggling these anchors, I can do that easy enough in my scene view and see what it's going to look like in the game view. All right, we created our cube. Next on the agenda was to create our border objects. The important thing to do here is right-click on the cube itself, because we want to create child objects that are going to move along with this cube as we're going through. So I'm going to make my first cube object. We're not going to be able to see it initially. It's going to be a cube that's right in here. So we won't be able to see it in our scene, our game view, but if we want to move it up, we can kind of get a feel for where it's at. But you can see that it's shown up as a child object inside this, inside our main cube, which I'll rename at this point. All right, I want this to be a little bit smaller, so I'm going to start tweaking the scale on the Y, which is the green arrow over in my scene view. So if you notice I always want to call this a gizmo, but is it a gizmo? I don't know if it's a gizmo or if this is just my what have you. So if you're looking here, it'll kind of give you a rough idea of which direction you're facing. So for the most part, we're not going to be working a whole lot with Z. We're going to be working with X and Y. I'm going to tweak the Y down to like 0.2. No, let's go 0.1. And that's already getting a little bit hard to see. Let's make a material and let's color this thing something different. I'm not going to worry about folder structure or anything like that, because we're only going to create a handful of scripts and materials and things like that. Down here in the project, right click, create material. I'm going to name it black, because we're going to have our black hole later. With that material selected, I'll pick a color. I'm going to pick black for this one. This is not working. Nope, it's probably showing up on my screen down here. Just realized. It's showing up on my other display. So we'll make that one black. I'm not going to mess around with any of the other settings of it. I'm going to do that same thing again. I'm going to make one that's red for these borders. Just call it red. We'll make it a little bit darker than like full red. And easily enough, I can drag my material right onto my object and it'll color it right there for me. All right, now it's a little bit easier for me to see. So I want to try and get this thing down. I'm not using any like snaps or anything like that. I'm just kind of eyeballing this for right now. I want to get this thing right up against the main cube. And it looks about good. And I'm going to bring it out in the X a little bit. I think if we just go with 1.2, I think that's going to work well for what we're doing here. So we're just making borders, and eventually we're going to get rid of this white cube and pretty much everything that it would render on the screen, so that we can have this, we can control this object, our main cube, and the cube border objects will just follow along with it. All right. Now I just want to kind of run through and create some new ones here. I'm going to duplicate this object. You can right click the cube. Remember, this is the child cube item, and duplicate it. It's duplicating it in place right now, but you can see I've actually got another object here. I'm going to move it down and try and do the same thing down here. Just eyeballing it so it's about at the edge of that cube. Looks good to me. Another keyboard shortcut on the Mac, it's Command D. I think it's Control D on Windows. If you want to just duplicate another object, I'm going to do it again because we need to make our other two walls. I duplicated it in place, so I'm going to rotate this guy 90 on the Z-axis, and I'm going to drag it around until I get it in a place that I like.
So can you can't remove like remove a hole in the middle of something like so square. I can see you can do this, but like a circle, it would not be.
You might choose to do it differently depending on whether or not you're in a 2D or 3D environment. Like you could start with a sphere as your base object, or you could import your own your own assets.
You can't, like, remove a cylinder out of the middle of a cube.
You probably can. I just don't know how.
You're probably looking at custom 3D modeling at that point, but there
Yeah.
are tools on the asset store that would give you that kind of like carving.
Yeah.
Along that same idea, you use like 3ds Max to be able to print
Yeah,
out.
yeah.
That's usually what you would be doing. This Unity's built-in shapes are good for prototyping or
Yeah.
demoing things like this. But
Yeah.
normally, in a normal game workflow, you would be creating the 3D assets in a tool like 3D Studio or Maya or Blender, and then importing them in.
So they would have their own definitive border markings and things like that. So if
You
it,
can use any of those objects.
Yeah.
It's like you're going to use a cube here.
yeah, when you built it in like a tool like Blender or something like that, it would have, for example, maybe if you wanted to build like a torus, like a donut, you would build an object that would have a hole in it, and that would be demarcated. That would be marked in that actual model. So when it came in, that would be considered empty space to Unity.
And plug for Blender because it's free.
Exactly. I've heard the learning curve is not necessarily the easiest, but I've seen Greg work in it. It's pretty impressive.
The best. And it's gotten better with the
All right, we're just about done with our borders here, and I'm going to duplicate this one more time and eyeball this thing here. That looks pretty decent. All right, I'm going to zoom out just a little bit and make sure that I got all my dimensions right. So I've got a Z. I intentionally left the main cube scaled at 2.75 on the X and Y and 1 on Z, just so it wasn't this ridiculously deep box. Our camera is only going to be looking directly at it, like we're seeing in the game view. So if you remember from the slide, we're basically just kind of looking, it's top down or face forward, depending on which way you want to think of it. So at this point, we've got our box. These things have box collider components on them. So for the purposes of this demo, they're just going to live here. They will exist, and they will deflect objects. They will prevent objects from going directly through them with a couple other tweaks that we'll talk about in a minute. The last thing I want to do is I want to rotate my main cube. So make sure that none of your side cubes are there, but you want to rotate your main cube on the Z 45. So this is how it's going to start when the player starts their view. And then in a perfect world, we would have time to add little hints or UI elements that would say, swipe your finger, all around, whatever it is. For the most part, we're just going to be using the mouse to simulate swipes that you could on a mobile platform. The code that we're going to be using would be suitable for touches as well as mouse clicks. All right, I lied. The almost last thing we're going to do. We also wanted to do a couple other things on the main cube. We want to get rid of this mesh renderer. For right now, I'm just going to uncheck it. You could also go over to the the cog over here and remove the component altogether. I'm just going to kind of show you visually what it does. You also want to remove this box collider. If that box collider stays on that cube, that actually gave me a headache for about 20 minutes before I finally figured out why my ball was bouncing really strange, because there was this invisible ball collider or box collider that I wasn't actually seeing. Out of the box, Unity tries to help you. When you're putting a cube into an environment, it thinks that it should be a physical object. You'll find in Unity it's often advantageous to model things as real world objects. And we'll touch on that again in a minute here. All right. Next thing we're going to do, we've got our basic cube there. So now we want to add some hooks to be able to control this thing with a mouse click or our finger. This is where the C# scripting comes in. We'll come over here and we'll add a new component. You can type in script or C# or something like that. We're going to name it not creatively cube rotator. And you'll see it created a new script for us down here in the project. And it's attached to, that script is already attached to the main cube. So anything that's in this script in the object-oriented this capacity should refer to this main cube. So if I say this main cube rotate 10 degrees, it should rotate the cube and any child objects 10 degrees, for example.
They don't have to be touching it, right?
Hmm?
They don't have to be touching it.
Correct. Yeah, if I wanted to move one of my walls, let's say that I wanted a more difficult level or something later, I could move this wall all the way out here. And if I'm rotating this main cube, all of those things would rotate around that same point, around that object's center, basically.
Just curious, can you build the entire level that way then, and have the level itself rotate around the player?
Sure. Yeah, you might just be like, it might just be camera movement as opposed to what we're going to be doing. Our camera's not going to move, and for me personally, I have a hard time conceptualizing it. So for the purposes of the demo, I was like, well, let's just do a top-down thing. We won't worry about a lot of camera movement. But yeah, the sky is pretty much the limit with Unity. If you can imagine it, there's a pretty good chance you can program it. Whether it's trivial or not is another conversation. All right, so we created this new cube rotator script. Double-click it. Your default install, I think, as of the 2018 4.1F1, I think it's going to open up in Visual Studio Community. I think is that the default install at this point? It used to be mono-develop. I have mine set up to use VS Code. I'm not worried about updating it right now, but this is the editor that we're going to be using in here for right now. So I'm going to try and zoom in slightly, and I can't find the keyboard shortcut for it. Is it this? There we go. So you guys can potentially actually see what's going on here. So by default, your scripts are going to have a start and an update method. There are lots of other hooks that a game object has inheriting from this mono behavior class. Start is what's going to happen when an object wakes up. So when your game starts, we're not going into anything really advanced where we need to do something before or right after start. So I don't think that we actually need to do anything in start, but so we're going to go ahead and just gut that method. If it's not there, it just won't do anything. This is one of those examples I was talking about earlier where code can run multiple times per second. So in a utopian scenario, a lot of successful games target running at 60 frames per second. That means that this update method could run up to 60 times per second, assuming your code finishes in 1/60th of a second and it can move on to the next frame. So what we want to do inside this update method is detect whether or not there is mouse movement, mouse clickage, basically. We have a click and drag functionality. You want to be able to touch the screen or click the mouse and then swivel. So we want something to happen when we first click. We want to keep track of where that position is. And then as we move around, we want to throw a rotation onto that main cube after we've moved around. But we want to be definitive about which one is which. So there's an input object that we inherit from the mono behavior class. So I can say if input get mouse button down, and I'm not going to go into too many of the details about this. This is an axis of control in Unity. This can be left mouse button, right mouse button. This could be a wheel turning. This could be middle mouse button rolling, something like that. This is going to represent our left click, which is what we're going to see when we actually try to run this in Unity. So get mouse button down 0 is what we're looking for. So as I mentioned a minute ago, the first thing we want to do is track a screen position. So let's set up a private float, or a private vector3, and we're going to call it screen position. This is the thing that's going to track the initial click. So this get mouse button down will fire when the mouse button goes down, but it won't fire as the mouse button is down. It only fires the one time when you actually click the screen or click the mouse or what have you. We're going to use another method in a second to handle the drag effect. So we want to log our screen position. But the first thing we need to do is, when we talked about world versus screen space earlier, we need to convert the place on the screen where you clicked from world space to screen space, world dimensions to screen dimensions. Screen dimensions are in pixels, world dimensions are like meters or whatever your unit might be. So we have all of these great methods here. We only have one camera, so we can use camera.main. And we have a world to screen point, and we'll pass in this object. So maybe just for sake of this conversation, we'll say this. That's the game object we're on. This transform position. So world to screen point gives us a vector3 back, and we're going to track that. Okay, so the first time the mouse comes down, we're going to track that position. Track click position initially. Apologies for the spelling. The next thing that we want to do, we want to get the difference from the mouse. Okay, from where this object actually is. All right. We can do that with simple vector math. If you don't understand the vector math, for the purposes of this conversation, you can consider it basic subtraction. But if you have a vector here and a vector here, you can add, subtract, multiply, do whatever you want with them, and you'll be able to get those differences. So to indicate where in the world we actually are, or sorry, where on the screen we actually are, we're going to create a quick vector 3, and we're going to take input mouse position, and we're going to subtract the screen position from it. So this is, whoops, I wanted to call that V3. So this is that input object again. This is the mouse position where I actually clicked. And then this is saying, give me the difference where it is on the screen position. The last thing we want to do is calculate the angle offset. So back in our design, if I click down here and the current angle is facing this way, because remember when we rotated this thing 45 degrees right here, okay, you can see a little bit of movement right here. So if I go right back to 45, this is the up direction of this right now. So the angle that we're going to be looking for is right here. If this is the x-axis, this is the y-axis. We're going to be looking at this right here. So this is actually where I'm going to kick back over to the slides for 1 second and talk about the math that's behind this next statement. If you don't remember from your trig class what an arctangent is, we want this angle right here. So this is 0 degrees on the x-axis. This is the angle that our object is twisted to right now. We want to calculate an angle offset if we're, for example, say we click down here. All right. So we're going to take the arctangent of this, which at 45 degrees we know that it's at 45 degrees. The arctangent of this is going to be 45 degrees. And we're going to take the arctangent of the angle down here, for example. If I click down here, click up here, click down here, click right next to it, whatever it is. We want to track to make sure we know how much to offset as we continue to drag. So that's what the arctangent looks like. And then I have a graphical representation to kind of explain like where the world to screen stuff was. Forgive my crude drawings. These are literally like doodled on my dry erase board to kind of give you a depiction of how things are happening. Imagine this camera is closer to your face than this, the actual background. This is where the click is. Imagine if that little thing right there is a finger. So we're trying to convert this point right here into screen space from world space. And then the arctangent back here, this is that first angle we were talking about. This is the second angle. So let's say we clicked down here at minus 130 degrees. We want to find we want to track the difference between this 45 degree angle and this 130 degree angle at the beginning so that we continually offset the cube as we continue to rotate it. So again, forgive the crude drawing, but we're going to also see a transform.right in here in a second. That's going to be the x-axis. If you remember back in Unity, we looked at this. This x-axis right here is transform.right. So the transform component that's on this cube indicates where it is in the world. We want to reference transform.right as which direction it's pointing. So the actual angle that we want to track is going to be just a float value. We're just going to take, we could, if we wanted to track it in radians, that's fine. If not, I think that degrees is a little bit easier to work with. So we're just going to have a float variable called angle offset that we'll want to track.
You want to see if anybody knows the next line yet?
What's that?
You want to see if anybody knows what the next line is?
What the next line is? It looks scarier than it actually is. So that's why I was trying to like explain it visually before we just dove in and wrote it. So angle offset is going to be, Unity's got built-in math functions, things like, well, .NET has that as well, but there are some overlaps between .NET and Unity. So this is our arctangent function. We're not going to go into the difference between arctan and arctan2. This one is going to be transform right y component, transform right x component, and sorry guys, I have my cheat sheet down here. We said we were going to subtract the arctangent of the actual vector that we created, so v3 y component, v3 x component, and then we're multiplying that just for debugging or anything like that later, just a constant radian to degrees. So we would get radians out of this if you don't actually remember your trigonometry. Hopefully we can see all, yeah, we can see all of that on the one screen. So we're taking our objects transform, that angle 45 degrees minus the 130 degrees minus the 130 degrees minus the minus 45 degrees, depending on where we actually clicked, and we're just tracking that offset, okay? This is just on the first one. We haven't actually moved the main cube yet at this point. That's where the input get mouse button code comes in that I talked about a second ago. So I'll stop there for a moment. Is anybody just completely lost with what we just did?
Is that a multiplication at the very end of that last line?
Yes.
Okay.
Yeah, and this is just, again, to convert this float. This is just a constant. So 57.29578, if you happen to remember that, that's just going to be, that's number of radians in pi, right? Am I saying, I can't remember if I'm saying that right. Just the conversion factor. So if we need to put any like debug statements or anything like that, it's going to be a little bit easier to say, here's 0 degrees. I know where 45 is. I know where 130 is. I know where 180 is, as opposed to 3.14. I'd have to remember that that's 1 pi, and that's going to be 380 basically. All right. Next thing we're going to do is the actual the dragging of the mouse. So we mentioned we were looking at the get mouse button down before. Now we're going to be looking at input get mouse button. Same button. So this is going to fire every frame, since we're inside of our update method. It's going to fire every frame as long as my mouse button is down. It can't possibly be down without already having clicked. So the screen position, angle offset, things like that, we can rely on in this segment of code as having run guaranteed, basically, without that. Are you here for the meetup?
I was just wondering, what is this?
This is the Frederick.net meetup. We're doing a presentation on game development.
Really?
Yeah. If you're interested, you can grab a seat.
What days do y'all meet up?
It's just kind of ad hoc. So this was just one I scheduled a few weeks back.
Do you have a website or anything that I can reach out to, like?
Not anything that's specific to here, but you can go to meetup.com or check out the meetup.com app. If you've got a mobile phone, check that out. And that there's a bunch of tech meetups that are in the area if you wanted to participate. Mm-hmm. All right. So
Right?
yeah, meetup.com. That's a first. All right. So we were talking about the mouse click actually remaining down. So in this case, now that we've already got our screen position and angle offset tracked, we want to calculate the difference between the original screen position of the object. So the first thing we'll do is we'll grab a new local vector. We'll grab the mouse position and subtract the screen position that we stored up there. So again, this is basically calculating difference between original position of let's see, object on screen. All right. The next thing we need to do is figure out how much to actually move. So we take that difference because that's what we've moved since the last frame or since this calculation was done. So we need to figure out how much to actually move it. We're not actually applying the angle offset yet. We're just going to figure out real quick by what angle we need to move this, rotate this object by. So here comes another arctangent. And we're just taking the arctangent of that vector. And it's y over x. So remember, if you remember the arctangent, it's the angle whose tangent is y over x, which is why the y and x parameters are in this order. And we'll multiply that by our radians to degrees. All right. So this one was, again, just figure out how much to move, okay? Now we're actually gonna move it, all right? So we'll take this object's transform, and we're going to use the Euler angles. This is basically, we're just going to set this one right here, the rotation as Euler angles in degrees. So we're going to be able to pass this a vector with the angle offset in it. That vector will indicate which direction, where to move it to. So if you drag the mouse faster, this right here, this angle is going to be larger. This vector will have been that much different than the screen position. So when we set that new angle, this is where it's actually going to move to. So we just take 0, 0, and we only want to move on the z, so angle plus angle offset. All right, so this is what will actually move it. So we are going to move, or sorry, I guess instead of move, we can say rotate specifically. So rotate this object by that much plus the offset. So instead of saying that much, I can say by angle plus angle offset. All right. There are ways to do this with another thing in Unity called quaternions. I don't fully understand them. There are probably ways to do this in fewer or maybe more complex lines of code. This was just kind of what I opted to do because I thought I could explain it to you guys well enough. So hopefully you guys are still with me. I recognize that it's not, if you haven't had a trig class, you're not into game development regularly, the movement seems really weird. I promise you get used to it if you keep up with your game development. So I'll pause momentarily there before we dive back into the slides. Is anybody just completely and utterly lost?
You have a question.
Shoot.
Why do you have two if statements with the same?
One's when the
Oh,
mouse
it's
goes
get-
down, and one's
Yep.
Oh, continuously down.
Yeah. So this one, this get mouse button down is only going to fire on the first frame when the mouse button comes down. It's going to say, okay, I'm going to start rendering that frame, and then it's going to say, all right, mouse button went down. Or left mouse button went down is why the 0 is passed. It won't fire again on the next frame because the mouse button didn't go down since that last frame. And then this get mouse button is the one that kind of indicates the drag. You could do this with on mouse up, on mouse down, or on mouse drag. The disadvantage to that is you'd have to click on the object itself. Whereas in our application, I thought that the UI might be a little bit better by clicking anywhere on the screen. So basically tracking anywhere you click on the screen, and then if you click and drag from there, it'll track that movement, and the cube should rotate well. It should rotate in an intuitive way, kind of. Does that make sense?
Yes.
Okay, cool.
I have a question. So
Shoot.
Update will try to fire 60 times a second.
Mm-hmm.
And if it doesn't finish in a 60th of a second, they won't pile up.
Well, they will. I don't exactly remember how the engine manages it. So when you get frame rate reduction, so if there are profiling tools right within Unity that you can show frames. So if you were to just start throwing some like thread.sleeps or something like that to demonstrate it, you'd see that the frame rate would degrade. The frames are still going to attempt to fire, but there's no guarantee that you're going to get 60 per second if your code is running inefficiently. With lightweight mathematical calculations like this, we're talking about millisecond calculations per frame. So there's going to be more than enough time. If we weren't able to run this at 60 frames per second, I'd be pretty surprised. You're going to see a little bit of fluctuation down to like 58 a couple times if you try to spin a bunch, maybe. But
normally for movement for various parts of this, maybe this math, I'm not sure, but for various things you would multiply it by time dot delta time.
Yep.
Which will adjust your calculations to for the
Yeah.
the duration of time since the last frame. So if there's a lag in the frame rate, then things will still move at the right.
They'll blend in.
Yeah.
People have constant speed for somebody that's
Yeah.
at 30 frames per second versus 60.
There's a lot of really cool functions that are built into Unity that will take that time.delta time or a multiplier, multiplying something by that, that'll allow you to do that. There's like lerping and all kinds of stuff that you can do to kind of say, move it this much, but only move it by this much because I'm only within one frame.
So, but if you don't do that, is it guaranteed to call that handler 60 times and all 60 of those will finish?
Should.
Eventually?
Mm-hmm. Yeah, I don't know if there's a way that it can like kick frames out if it knows that it's being degraded. Like if it knows that it's slowing down, will it evict threads
I
or?
think it will complete the update, but
Okay.
just stall the whole runtime. Like,
Yeah.
It will actually like
Push it off.
And you will feel the
you'll
game
be getting
slower.
Fewer
Yeah.
frames, yeah.
Yeah.
Cool, sorry.
All right, so I'm going to try and run through this part. There's not a whole lot to making the ball actually move around. We're going to make a sphere. We're going to scale it. This is just kind of a trial and error thing when you're trying to prototype something like this. We're going to lock it down to a few different axes so that it can't move certain ways, and it'll make our lives a little bit easier because in 3D space, if we just kind of let a ball go, eventually if it bounces off of a wall, it might eventually rotate itself out of the box. We're going to lock it down on a few axes and on a way of rotating to prevent that. We're going to talk about, we're going to add another type of material called a physics material. We're going to make this ball bouncy, okay? There's a couple quick properties that we'll add. We're going to add another component called a rigid body. A rigid body is going to it's kind of a way of saying, I am physically in my game world, so treat me as something that you could apply gravity to or other forces to or things like that. We're going to do another script, and then hopefully it'll all work from there. So we will flip back over to Unity, and let's add a sphere. So same way we did it over here in the hierarchy, we're just going to click in the empty space, right-click in the empty space, 3D object, and add a sphere. Come over here to the inspector and reset it. We said we were going to scale it down to 0.25. I think that was about the size that I had it. Maybe it was like 0.3. I think that's about good. We're going to start it in the center for right now. We're not going to worry about moving it around. You can see that the sphere, similar to the cube, came with a mesh renderer and a sphere collider out of the box. So the mesh renderer is basically just what shows it on the screen. The sphere collider is what allows it to collide with other objects. Those are things that Unity will try to give you out of the box for free. We wanted to freeze this several different ways. So that must have been on the rigid body. I had those out of order, I think. We're going to add a component. We're going to add a rigid body, not 2D. So this is what we can apply mass, drag, all kinds of things like that. We do not want to use gravity. We're going to control this object basically ourselves. We're going to set a velocity and a vector of direction to start it off in a more intuitive or a better qualitative game world. You would randomize the direction that it would start or something like that. For the purposes of this demo, we're just going to be quick about it. We're going to lock down rotation for this object because it doesn't make sense for this thing to rotate at all. It just needs to bounce. And we're also going to freeze the z-axis. So regardless of what happens in the physics, with the physics of this or with the velocity, direction it's moving, what impacts it, whatever, it'll never move off of the z-axis. So z is this blue hook right here. So it will never be able to move this way and eventually come out of our box, basically. And I think I wanted to bump this up actually just a little bit because I think it's pretty close to like the bottom of the box. Let me move this up just a hair. And I think that'll look a little bit better. Actually, if we move it up a little bit more, yeah, you can start to see the shadow encroach on one of those borders. So we'll keep that like right there. All right, we need to add a bouncy physics material. So we can add component. We wanted to create a new physics material. That is not the material that's up here. This is a physics material. We're going to call it bouncy. We're going to get rid of its friction, set its bounciness all the way up. No friction, bounce combined maximum. Don't worry about the specifics of these properties. These were this is just part of the research that went into the demo that made this work. There's one other thing that we need to do before we actually stick this bouncy physics property on our ball. we need to go into our project settings. If you go to File and, nope, I'm sorry, Edit Project Settings. Oh, I already had my tab open. Your tab may open somewhere else and it may look a little bit different than this. We want to tweak our bounce threshold. If we hover over this, it says a contact with a relative velocity below this will not bounce. For shallow angles, as the ball is coming in on some edges, its X or Y velocity might be less than 2 and it might not bounce and it might appear to get stuck to the wall. So I'm just going to change this to something really, really low. This way, unless it's moving at like the most extreme steep of angles, it won't appear to get stuck, basically. That's one other thing that gave me a little bit of a headache trying to get this thing ready, but we prevailed. All right. So we froze the ball, scaled it correctly, added a rigid body, we didn't apply the bouncy physics material. We just need to drag our material onto our sphere. And we can see that the sphere collider material changed to this bouncy material. So this is what's actually going to apply it. So the mesh renderer has a material that not the mesh renderer, the mesh filter. Nope. Where's the thing that usually has this is what I was looking for, the default material. So if we wanted to drag red or black or some new material on it, we could. This physic material is different than that. All right, the last thing we're gonna do is add a script to this again. And we're gonna call this one ball manager, and for lack of a better term. So we got a new script created down here in our project, and it's attached to our sphere. So we'll double click it and open it up in our editor of choice. Whoops. And I'm going to come down here to my cheat sheet. We just want to apply an initial velocity to this. We're not going to be doing anything when it actually updates, but we do want to keep track of the rigid body. We don't want to have to look that up well, I guess it doesn't necessarily matter in this case. We're only going to be doing it on start, so we don't need to track that rigid body. So I'm going to get that rigid body with a method built into mono behavior called getComponent. That's just going to get the rigid body component right on our sphere. So it's just going to give me this component so I can do different things to it. Namely, change its velocity, basically. The first thing that I'm going to do is just create a quick vector to describe its initial movement. And it's just going to be a static value. Let's go with minus 1.25 in the X, positive 2 in the Y, nothing in the Z. And I didn't give my, I had too many equal signs in there. The last thing we do is just apply set that velocity to it. Initial movement, and we're going to multiply this by some factor of whatever. We might have to play with that value. I'm just going to call it 2 for now, and we'll see what see how fast the ball actually moves. So when the application actually starts up, we should have a sphere that the sphere should just start moving on its own and should start bouncing. At this point, we can actually fire up.
Did you give a direction there, David?
What's that?
Did you give a direction? I missed that. Did you give a direction?
Yes.
Okay.
So the direction was this right here.
Okay.
So this is a vector. So if you're at origin, you go minus 1.25 in the X, 2 in the Y. So the vector from origin to that point will indicate its initial movement. Did I do that right? Minus 1.25, and then 2 down. Sorry, I think it's going to go 2 down. I'm not 100% sure on that.
Velocity is direction times the speed.
This is just a magnitude multiplier. So this is just the vector, and this is just saying make the vector bigger. So we could expose a public property or something like that to let the designer do something in the editor, but I'm just trying to kind of speed things up on the fly since we're pushing right up on 8 o'clock. We don't have to stop immediately at 8, but that's when we typically try to stop. So I just want to try and get through something to show that we've actually done something during this talk. At this point, I think if we are lucky, we should be able to run this and at least see some functionality. So we've got our ball, it bounces around at that speed 2, and if everything worked well, I jumped it first. Damn. I missed something. See how sometimes the first time I click, it's changing its initial orientation. So I'm off somewhere. It still works if I want to spin this around a million different ways. Oh, and it fell out. But it was that jarring experience. So it might have to do with that initial. So let's change this. Let's move this down to like 1.2 or something like that. So the collider on these boxes might not be wide enough to account for the speed. And if it travels more than the distance of that collider in one frame, the next time it renders, it's just outside the box. It's through that actual object. Yeah, you see how it kind of jars? So I must have missed something slightly. It works okay if you click right in the exact same. Oh no, it's actually not in the exact same spot. See what maybe that's what it is. Well, no, the blue is the. Oh, sorry. The box is rotating on the z-axis. That's the blue, right? Yeah. Okay. Well, in any event, we got something there. So for the purposes of the prototype, if anybody has to leave now, by all means, I'll try to just really speed through the last part where we're going to add this sphere. We won't worry about the specifics of why that didn't actually work. Maybe we can address that if we have time, if anybody else wants to stick around for it. So for this, we wanted that black sphere. It's going to be slightly larger than the white one, and that's the target object, basically. I think we're just going to stub in some console messages instead of trying to do anything else in the interest of speed. So we're going to make another sphere, set it to this scale, put it somewhere challenging, somewhere that it's not just going to bounce immediately into. We'll add a script, and then we'll talk about what it takes to look at those colliders. This is the loose math that it takes to determine whether or not that smaller collider is completely inside of the larger collider. We take the distance between the two centers of the circle. So this is the center of the larger circle, center of the smaller circle. Calculate that distance, which is really easy in Unity. There's lots of things that it's already got. And make sure that it's less than the larger radius minus the smaller radius. That will guarantee that this circle is definitively inside of this circle, or our sphere in this case. Doesn't matter that we're working in 2D space since we're constraining all of our axes. So we will add another sphere. We'll reset it. So it's going to be big. We're going to put the black material that we made earlier on it. You can see it's kind of overlapping the white one at this point. We're going to move it over a little bit. And we said we were going to scale this down to like 0.5. So you see that it's still big enough that the white one could fit completely inside of it. I wonder if you actually scaled this down to 0.3, I wonder if that math would still work, if you'd ever be able to get it exactly inside of that collider. But for the purposes of this, I think it's easy enough to do it like this. We also want to make this sphere, this sphere collider, we actually don't want the ball to bounce off of it, okay? This is trigger right here is where we start with that. That means that the ball will be able to go right through it. So if we play this right now with that is trigger check on, and I can actually get this thing to bounce through it. Let's see if we can get it. So it'll go right through that, okay? Or right on top of it if it actually happens to be in a different position than it is in the scene. But there are events that we can hook into. So surprise, surprise, we add another script here. We'll call this collider. We'll open it up, and we're going to hook into a method called onTriggerStay. Basically, it just means that that's what fires whenever there is some type of collision, I think since the last frame. There's still a collision since the last frame. A lot of these methods are documented really well. Actually, I'm going to do this. I'm going to copy and paste from my cheat sheet, and we'll just kind of talk through this code. Whoops. Oh, I missed the actual method. Sorry about that. The documentation for Unity, a lot of these random methods that you wouldn't ordinarily know maybe as a .NET developer are documented really well. It's just kind of it's a function of getting to know the lingo, basically. So this onTriggerStay gets past the collider of the other object. If the other tag is player, which I think I had changed which I did not change in this demo. This is where you set the tag. One of the default tags is player. This is just how you can kind of identify a specific object. If you maybe place the black hole too close to the edge, you'd want to make sure that it didn't try to run this with the border, with the red border inside of that. So this is just quickly how we actually do that math. And this is our debug log statement that will say, I'm completely inside of the collider. So if we open our console up while we're running this and we play around, we're going to get this printed a number of times because this on trigger stay is going to fire every frame that this math is satisfied. So every frame that the white ball is inside of the black ball, it will fire.
Might actually trigger multiple times per frame.
It could trigger multiple times per frame.
Physics steps are.
Oh, that's right. They happen off of. Yeah. Okay. Good to know. All right. So we'll see if we can play this. Let it rebuild. And I will open the console. Is that a current error? I'm not sure if that's a current error or not. Let's see if we can get this thing. Almost. It must be a current error. What is this telling me? This is telling me that on trigger stay has to take a collider. Has to be a type collider. Am I missing a namespace or something? Or did it did it not rebuild?
Is it trigger? Is it collider or trigger?
On trigger stay has to be of type collider. This message will be ignored.
I'm actually wondering if calling that class Collider is causing a conflict. 'Cause that's the actual class name of the.
Good call. Yep. Black hole collider. And we'll rename the script for posterity's sake. Thank you guys. Let's see if that fixed it. That makes sense. No errors, hooray. So now let's see if we can get our message to fire. If I can actually get this thing. Bam. Oh, come on, that should have worked. You know what? It is off center. So our scene, if we move over this way, yep, we're gonna see that it's way off. So if I grab this and I move it like here to whatever the Z was of my actual sphere is probably what I should move it to. So it's actually at the center. I think that should probably do. Let's move back over to our console.
So when it's doing all that math, is that the widest point of the sphere?
Sorry?
So if you slice the spheres directly down the center, so it would be wider, but if you were doing the math towards the edge, it would get like a smaller circle, right? I assume that math would be directly at the center.
Yeah, it would be directly at the center. So is it that the Z just needs to be identical to this for us to get it? So here's our sphere. Let's grab that value. Well, I moved the one up a little bit. I moved it out from where the default location was. So it was kind of in the middle of the box. I think this might be what. It should be close, but I'm wondering if it's just not close enough to actually make this work.
They are colliding. It looks like the delta comparison is not what's provided.
Yeah, so it's still just slightly off. All right, so let's see if we can fix this quickly. It does still look like that's off, doesn't it?
Yeah.
Yeah, we can do that. Let's do that. That's a good idea. Let's scale this to. Whoops. Cool. Let's try that.
That works.
Hopefully that's big enough. And it should make it really easy. Let's see if we got some console logs. Oh, we still didn't. It should be in there. It must still just be slightly off. I'm looking here at my my backup to see what the actual values were. I had the ball at minus 0.25, and I also had the black hole at minus 0.25. But if I'm moving them both, it shouldn't matter, right? The
Yep.
thank you. That would do it. So we'll take our black hole collider and put it back on here. That would probably be the issue. Nice. There we go.
Yeah.
So we saw we had multiple fires there, and we prototyped our game. So just real quick follow up. I will put these the slides and everything on here. This was the stuff that we were theoretically going to have time for. I had some text in my initial one, which I can flip over to the screen here. So this was the one that I was kind of cheating off of. So I had a timer that actually runs on here. I started wiring up the score stuff with a couple lines of code, like as I actually came in here. And you can see in this one, regardless of where I click and lift up and click, the cube will always rotate from that position. So I probably missed like, you know, one thing somewhere. And I have the completely inside the collider stuff and all of that. So it's really close. I'll go ahead and post the one that is fully functional that works. And I'll make a note or something in the meetup about, you know, what was missed there. And I've also got one slide here, just a handful of links for some of the stuff we talked about. This link in particular was pretty helpful when I was trying to figure out how to get the cube rotation working. And these are just some, these two links are just some actual references to Unity docs for Sphere Collider, World to Screen Point. Not the most intuitive concepts, but that's just kind of where that was. And that was it. So thank you. Thanks guys for coming out. Questions there. We probably, you know, we can probably stick around another like 5-10 minutes, but I'm going to start like cleaning up and kicking everybody out. But I really appreciate you guys coming out, showing support, and hope you learned something. Like literally just one thing I'd be happy with. So.
If you do want to rename a class in Unity, it's best to rename it in the Unity editor.
Right. It would do that within the components. Yeah.